rate forward contracts. Let's discuss a few terms, and we're going to have separate slides for each of these terms. So this is just an initial discussion, and then we'll have separate slides for each of these terms. Let's start with yield to maturity. Now let's say there is a bond that pays a coupon payment of $10 1 year from now, and then another $10 1 year from now, and then it will pay its face value back, which is $100, and that bond is currently available in the market for $100. Now, since these payments are coming after 1 year, after 2 years, after 3 years, so we have to take their present value, right? So it will be 1 plus r to the power 1, and this will be discounted for 2 years, so it will be 1 plus r to the power 2. This will be discounted for 3 years, which is 1 plus r to the power 3. Now, the value of r at which the present value of all these future cash flows will become equal to the current market price. So the value of r at which the present value is equal to current price, that is called the yield to maturity. So because that is actually the return this bond is earning for you, and if you will discount it at its existing return, then the present value will be equal to the price you are paying, and that is called what the bond will yield for you if you hold it till maturity. Now this bond has coupon payments. First year it's paying you $10, second year it's paying you $10, and the third year it's giving you the face value back. If let's say there are no coupon payments and there is only a face value coming back, right, after let's say 1 year, and it's in the market available for $100 right now, so the rate at which you have to discount it back, that rate is called the zero rate. This r will be the zero rate, and that only is the case when there are no coupons. However, sometimes what happens is that we have a bond like the one we discussed in the first situation where there are coupon rates, and we need to calculate, let's say, the zero rate for the third year. Then in that situation, what we do is a process called bootstrapping, and I'm going to explain that whole process in a separate slide, but I'll just give you an initial introduction here, that what we basically do is that we take the zero rate for the year 1 cash flow, and we take the zero rate of year 2 for the year 2 cash flow, and then we calculate for the year 3 rate. But just hold on to that thought. I'll explain it in the second a separate slide for zero rates properly. Now, a little bit discussion about discount factors. So let's say we're going to get $1 after 1 year, and the present value of that $1, if you divide it by 1 plus r, is let's say $0.97. So this 0.97 is what we call the discount factor. And why we calculate it like this is because, for example, if somebody tells you, oh, I'll give you $500 next year, and you want to calculate the present value of that $500, all you have to do is multiply it with this present factor, and you will be able to calculate the present value. All you have to do is multiply it with the discount factor, and you can easily calculate the present value of any amount of money, whether it is 500 or 1000 or 2000. So this is what a discount factor is. Forward rates. Now let's say we are here, and at time is equal to 0, and we want a loan that we don't need right now. We'll need the loan after 1 year from now. Let's say we're setting up a factory, and that factory will only be set up after 1 year, and it will produce after 1 year for another year. We have to make a special consignment. So we need this loan not now, but starting after 1 year. So what will be the rate of interest at which we will be able to get this loan if the loan will start after 1 year and it will end after another year? So the way we actually write it is that we need a rate for a loan which will start in 1 year and will be for 1 year after that, right? So for this period we calculate, and I will show you on a separate slide how to actually calculate that rate. And when we take that rate and get into an agreement to pay that rate, so on one side we're going to be paying a fixed rate. Let's say that rate comes to 2.5%, right? So we will get into an agreement to pay 2.5% for 1 year, starting after 1 year. Now, on the other hand, we will receive whatever is the market rate at the time. And naturally, if by that time, let's say the market interest rate goes up to 3, then we'll be happy because we have to pay 2.5 and we'll receive 3. And it could be the other way around as well. So whichever party is long the forward rate agreement, it's like they are buying the interest rate and they are locking it at this price, and if the actual market rate goes up, they will benefit. Now let me explain each of these concepts on separate slides, starting with yield to maturity. Now here we have 3 different bonds. One bond which is maturing in 1 year, another bond which is maturing in 2 years, and another bond which is maturing in 3 years. This bond is paying a coupon of 1.5%, this bond is paying a coupon of 2.5%, this bond is paying a coupon of 3.5%. This is the current value of this bond, the present value or the price in the market. This is the present value of this bond and this is the present value of this bond. Now to calculate the YTM, what we can do is you can use your calculator. For the first bond, you can enter the number of years as 1. The present value we're entering in negative because this is something you have to pay to purchase the bond. But the payment is something that will be entered in positive because this is the money you will receive. And the future value is the face value which you will get once the bond matures. And then all you can do is press compute and IY, and what you will get is the yield to maturity. You can do the same process for the bond number 2, which is 2 years. Present value is going to be negative because you're going to pay this money. Payment will be positive because you will receive this money, and future value is going to be positive as well because you will receive this money, and you can calculate the YTM, and you can do that for the third bond as well. Now coming to the zero rates. The first bond that we are talking about is maturing next year, and there is no coupon payments for that bond, right? Because it is maturing next year. So it's very easy to know the zero rate for this because the YTM is the zero rate. Because since this bond has no coupon payments, we can know the zero rate for this. Now the complexity will start with the second and the third bond, because the second bond is going to have a coupon payment for 1 year, and then the next year it's going to have its face value. So what we do is something called bootstrapping, and what that means is that we will use the zero rate for the first bond, which is the year 1 bond, and we will use that zero rate to discount the first cash flow of the 2-year bond, and for the second year we know that it is maturing then, and we will calculate the YTM for that second year, which will be the zero rate for the second year. And then we will use the second year rate to do the second cash flow for the third bond. And let me demonstrate this on a separate slide. So the first one is easy because there are no coupon rates over here, and directly you can put the YTM as the zero rate. But for the one with 2 years, we have a coupon payment coming at the end of the first year, and we use the zero rate of the first bond to actually discount the first year payment of the second bond, and we compute the second year payment. And when you look at the third year bond, what we are doing is it has 2 coupon payments. The first year coupon payment we are calculating based on the first year bond. The second year coupon payment we are calculating based on the second year bond, and then we are using the equation to calculate the YTM or the zero rate for the third year. And this is called the process of bootstrapping. Now, discount factor is very simple, that if you are getting $1 1 year from now and you discount it back to today, and let's say it is equal to 0.97, so this is the discount factor, right? And it's very simple to calculate, and you can see the first year discount factor is 0.97, second year 0.93, and third year is 0.88. And you can see that it is getting lower, because the further out into the future the payment is, the lower its present value is going to be. And the discount factor can also be interpreted as the price of a zero coupon bond, which basically means that if a zero coupon bond is going to pay you, let's say $100 at the end of 1 year, then the price of that bond should be 97.6 right now in the market. So you can think about it like this as well. Now, forward rates, something we have discussed before, that if you need to get a loan 1 year from now for a period of 1 year, so the loan will start in 1 year and it will be for a period of 1 year. So what you will say is, I need a rate which will start in 1 year and it will be for a 1 year period. Here it says for starting after 2 years and for a period of 3 years, which means this will be starting after 2 years, and then after 2 years it's going to be there for another 3 years. So the total number of years in this loan is going to be 5, because let's say this is 0 and you're going to start your loan after 2 years, and then you will have that loan for another 3 years from that point onwards. So that is what F2 comma 3 means, that it will start at this point and it will end at this point. So total is going to be at the end of year 5. Now, how do we calculate this rate? Let's say if you have the rate for 1 year, you have the rate for 2 years, and you have the rate for 3 years. Now you need to calculate what will be the rate at this point if you start after 1 year and you pay the interest for 1 year. So what will be this rate? So that is what we're going to demonstrate right now. So let's say if we were to just look at the 1 year rate, which means $100 multiplied invested at 2.4% approximately, will become 102.4, right? So this 2396, if you just round it off to 2.4%, so your $100 becomes 102.4. And let's say if instead of 1 year we invested for 2 years, so our $100 will become first 103.4 and then it will become 106.9, because this is going to be compounded for 2 years. So now that means if we put the money for 1 year, it becomes 102. If we put the money for 2 years, it becomes 106. Now we need to calculate what should be this rate in the middle, the implied forward rate. And that you can see can be calculated using this formula, that we say, okay, if we take $100 and we multiply it with 1.024 for 1 year, and then what will be the second year rate, which will make this amount equal to 100 multiplied with 1.034 to the power 2, right? And that is how we reverse calculate that the rate in the middle should be 4.45. So if we take 100 and it becomes 106.96, right, which is this part, it becomes 106.96, and this part, which is 102.4, needs to be multiplied to something which will make it 106.96. So what is that rate? And that turns out to be 4.4536. So this is how you calculate the implied forward rate. Now it's easy to do that sitting over here. If you know the rate for 1 year and 2 years, you can calculate the rate starting from 1 year from now and then ending 1 year after that. And this is how you would do it. So for example, we just did it for 2 years. We wanted to know, so we took the 1 year rate and we took the difference between the two, which is 2 minus 1. And for 1 year starting from now, and 2 minus 1 again will be, that is the loan rate starting 1 year from now and going on for 1 year, which is 2 minus 1. So that is how we calculate it. And if we do it for, let's say, starting in 2 years and then going on for another year, so naturally we will, on this side, we will take the 3 year amount that, okay, from here all the way to 1, 2, 3 years, what will become the $100 if we invest for 3 years. And then we compare it to if we invest it for 2 years, which is this one, and then another X rate over here, and what that is what we compute over here, and then it turns out that that will be 5.1719%. So this is how you calculate forward rates. And once you are done calculating the forward rates, you can actually get into an agreement for a forward rate. So let's say you need a loan 1 year from now for a period of 1 year. So, and you calculate that this rate, let's say, should be 4.4%. So you can lock this rate. Now, if the market interest rate, when you get to this point, let's say when you get here, and it turns out that the market interest rate has gone up to 5%. So you will be happy because you actually locked a rate which is lower than what you would have had to pay if you hadn't locked this rate, right? So in case the market reference rate goes up, the long party, the long position on the FRA will be happy. And how happy will they be? It depends on how much the loan amount is. So naturally the difference between these two, which will be 5 minus 4.4%, so 5% minus 4.4%, this difference will be multiplied with the loan amount. Let's say the loan amount is $100 million, then naturally you will multiply it with that amount. So let's look at an example. Let's say first we are here and we calculate the forward rate and we lock the transaction that we will borrow money at this point for this duration. Now when we actually get from here to here, we know what is the floating rate, because naturally we are going to be paying the fixed rate which we are locking, and we will be receiving the floating rate. So when we get to this point, this becomes clear that what this rate is, because you only know that rate when you get to this point, that okay, what is the rate you have to pay for this period. And of course the loan has to be settled at the end of the whole duration. So whatever settlement will be there, let's say this turns out to be 5% and this was locked at 4.4%. So the difference between the two will be 5 minus 4.4% multiplied by, let's say if we had $100 million loan. So that difference will be, the profit will be at this point. And if you want to calculate what is the value to you right now, you just need to bring it back from point of expiration of the contract to where you are right now. So FRAs are usually settled at the start of the loan. They don't wait for the loan to finish, because when you get to the start of the loan, already it is clear that what the floating rate is going to be, right, at the expiration, and you can just work backwards and calculate the profit as of the current situation. Okay, let's look at an example. So let's say there is a counterparty agreeing to be the FRA fixed rate receiver. Now here they are not long, they are short, because they are receiving the fixed rate. This is something important, right? Whenever you are long an FRA, you are paying the fixed rate. But if you are receiving the fixed rate, that means you are short the FRA. And if the interest rate will go down, then you will benefit in this situation. Here, if the interest rate will go up, then you will benefit if you are long, because you've locked the rate, and if you will receive a higher rate, then you will benefit, right? And this is a 1 month Australian dollar rate, and the notional amount is 150 million. And this contract will start 3 months from now, and it will be for 1 month. Okay, and the rate has been locked at 0.5. And 1 month later, the rate turns out to be 0.35. So now you can see that 0.35 is less than 0.5. Is less than 0.5, which means the long party will have a loss and the short party will have a gain. Why? Because the short party is the fixed receiver and they are getting the fixed rate, which is 0.5. So they are going to get a higher rate and they will be very happy. And how much happy will they be? It depends on the difference between 0.5 and 0.35, and you will multiply this difference with the notional amount, which is 150 million Australian dollars. Anyways, let's look at the solution here. So that is exactly what they've done. They've taken the difference of 0.5 minus 0.35 and they've multiplied it with 150 million dollars, and they've also multiplied it with 1 over 12 because this is a 1 month. This is a 1 month contract, not for the whole year. So only the interest rate is for the whole year, but since this loan is only for 1 month, so the benefit is only going to be there for 1 month, and this benefit is going to be at the end of the period, right? This is going to be at the end of the period, so you need to bring it back to where you are right now. So you need to discount it back, and that is what is happening over here, that they discounted back one period. I guess they forgot to write sorry. Yeah, so they're just dividing it by 12, which is taking the interest rate for 1 month, and they are discounting it back, and this is what your profit for the short party will be. Now let's look at the summary for all the learning outcomes. The first thing we discussed was the pricing and valuation of forward contracts. Now this pricing is something we've discussed in the previous learning outcome, as previous learning module as well. It's very simple. You take the spot price and you multiply it with 1 plus r to the power t, and you get the future price. Very, very simple if it is discrete. If it is continuous, we also looked at that you actually multiply it with e to the power rt. Right? Now the new concept over here was valuation, where we said whatever the spot price is at expiration and whatever the future price that you locked in, that the difference between that is the value of the contract at expiration. And if you want it during the life of the contract, then you will take the spot price during the life of the contract, and you will take the future price which you have locked, but you will not take the future price without discounting it, because if you want during the life of the contract, somewhere in the middle, then you are taking the spot price, but this future price also has to be brought back to today. So we discount it back to today, and what is today? It is big T minus small t, this difference between big T minus small t. And if there are any income or costs, then we need to adjust for that. So the value again for a life, during the life of the contract, you take the spot price, you minus the present value of any benefits, you add the present value of any costs, and then again, like before, you minus the future value of the contract brought back to today's price, today's value, present value. For FX contracts, it is simple. You take your spot for pricing and you multiply it with E. Instead of R, what we do is the risk-free rate of the foreign currency minus the risk-free rate of the domestic currency to the power T. And when we talk about value, we take the spot price at time T and we minus the future price that has been locked. But again, we discount it back to today, and how we do that is we divide it by E to the power risk-free rate of the foreign currency minus risk-free rate of the domestic currency multiplied by T minus big T minus small t. Now these terms we've just discussed in this video, I'll repeat them again. YTM is the discount rate at which, if you will discount a bond's cash flows, let's say a bond is paying $10 next year, $10 after that, and $100 after that, and you divide it by R1 plus R to the power 3 for the last one, 1 plus R to the power 2 for the second one, 1 plus R for the first one, and you get to a present value of 100. So whatever is this R that you are using, this is the YTM of this bond. Zero rates is basically if you have a bond paying $100 1 year from now and the present value is $100, so then the rate at which you will discount this, or let's say the present value is 99, so the rate at which you will discount this is going to be the zero coupon rate. And you can use the 1 year rate to calculate the zero rate for a 2 year bond, So for example, let's say this is the 1 year zero rate that we calculated, and now we've got a 2-year bond which is paying $10 1 year from now, and then $100 after 2 years. So we can use this rate over here, the 1 year rate over here, and we can then calculate the zero coupon rate for the second one by equating it to the present value. Now, discount factor is a fairly simple concept. If you have, let's say, $100 coming next year, and you calculate the present value of that $100, and let's say it comes to 97, so if for $1 it will be 0.97. So for a value of $1, if you calculate the present value, that becomes the discount factor. Forward rates, very interesting concept, that you, if let's say for example we want to find out what will be the rate for a loan starting after 1 year for a period of 1 year. So first we will say, okay, what is the rate for 2 years, and if we square that, and if we take the rate for 1 year and then we multiply it with another rate for 1 year, so what will that rate be, which will start for 1 year for another year? And that is something which you calculate using this formula, right? So let's say if this is for 2 and this is for 1, then you can calculate the forward rate for a loan starting after 1 year for 1 year, and you can do it for 3 or 4 or whatever combinations, depending on, let's say if you have 1, 2 and 3, sorry, 2 and 3, and you want to calculate this rate, then what you can do is make this part equal to 3 and 3 square, and then this part you can take the first year, and then you can these two you can take together as 2 years, and then you can calculate for the remaining part. And once you have calculated the forward rate, then you can even get into the forward rate agreement, that let's say we are going to get into this loan after 1 year for a period of 1 year, and let's say we lock that rate as 4.4%, and by the time we get to that point, turns out that the market interest rate has gone up to 5%, then the long party is going to benefit if the reference rate at expiration is greater than the rate that has been locked at the forward rate agreement. If the reference rate is lower, then the short party will benefit, which we saw in that example, that the rate which was locked was 0.5 and the market rate was 0.35. So the short party was benefiting in that example.